Hello.
All right, Professor.
Hi. I received an email from a student. Maybe some area has internet connection problem. It's okay. This class will be recorded. Then they will catch up later. Why I cannot see you, and then I cannot see me too. Yeah. Okay. Okay, how are you today?
Good. How are you?
Very good.
Okay, good. Yeah. Anything concern or anything question so far? Is it okay? Okay. Chapter 3. Forecasting. Okay, what is forecasting?
Predicting.
Predicting future. Thank you. Personally, I concern the weather. So every day I check the weather forecasting. And I like to play golf, go outside, but this time because of pandemic and also the weather, I cannot go out. But still, I check a couple of times every day weather. Next day, tomorrow, weekend weather, and so on. So maybe person to person different forecasting interest in, but for the company, what forecasting is the most important for the company? What do you think? Demand, you know. When company do business, they produce something or buy and sell, retail, whatever. They need to forecast future demand. If they know the future demand, then based on that forecasting, prepare material, plan, and so on like that. So in operations management for the company, demand is important forecasting. So demand management. Purpose of demand management, coordinating and controlling all sources such as material, resource, and so on. System can be used efficiently and the product delivery on time. So future demand is important. By the way, types of demand, there are two types: dependent demand and independent demand. Lauren, you writing everything? You don't need to write.
Oh, okay. I was just writing some notes.
You know, because the lecture notes is on Moodle. So if you can print out and then just add something, whatever you need. You don't have to write everything. Okay. So anyway, I post lecture note for every class on Moodle. So when you need, find that file and then print out. Okay. So Lauren, for your convenience, okay. Okay. There are two types of demand: independent and dependent and independent. I use this picture again, Toyota RAV4. If Toyota forecast next month's demand, let's say next month's forecast demand like the 1,000 cars, then automatically knows how many tires, except that tire in trunk, usually 4 tires, right? So times 4 and then 4,000 tires. So final product demand and then such like a part demand, tires, instrument panel, engine, and so on like that. So parts demand depending on final product demand. So come on. Dependent demand, the demand for a product or service caused by the demand for other product or services. So part demand is dependent demand. Independent demand, demand is not derived directly from that of other product, independent. So final products demand is independent demand. Next, components of demand. If demand, actual demand, this black line and dots like this, up and down, up and down. Average demand for the period from year 1 to year 4, up and down, but this is average demand. So add all demand divided by number of terms. Seasonal element, you know what, up and down, the same pattern come again and again, repeat. Such as ice cream demand. During the summer, high, during the winter, low, and then again. Seasonally, same pattern come again and repeat again and again. Then we can find that pattern that is seasonal element. How about cyclical element? The same as seasonal element. The same pattern, up and down, come again and again. Disregard the time, maybe, but the difference between seasonal and then cyclical element. Seasonal, if the same come again and again, like usually in the winter more flu come and summer low and so on. So seasonal element affected by the season. But cyclical element, I will show you something. This one is COVID-19 daily new case in Pennsylvania. Long-termly, it's increasing, decrease, and increase again, and then decrease. But in detail, up and down, up and down, up and down, and so on like this. You know, this one, the daily case of COVID-19 during the weekdays, high. During the weekend, low. And then weekday, up, down, and like that. Because of the week kind of a cycle. The Pennsylvania daily test, the same, up and down, during the weekday, more, weekend low, and so on like this. That is a cyclical element. Maybe it come again, repeat every week, maybe every month, maybe every year, maybe every 2 years, and so on. That is cyclical element. And then random variation, there is no pattern, just move randomly. If random variable in a data, then it's hard to forecast, use that data. And trend, here, up and down, but long-termly increasing. So for this example, trend is increasing trend. Maybe from this data, increasing trend, decreasing trend during this period, and then increase again, and then decrease now. So we can expect like next month, decrease, maybe, but who knows? So that is a trend, increasing trend, decreasing trend, maybe stable trend. Types of trend, linear. If it is a straight line, you know, if the function y equals a plus bx, exponent of the x variable is 1, then the line is straight. If exponent of x variable 2 or higher, then it can be curve. So linear trend may be curve trend. This one is an S-curve type. And S-curve trend, typical product life cycle. Typical product life cycle looks like S-curve. Typical product life cycle, there are 4 stages. Introduction stage, growth, maturity, and decline. So product life cycle, typically S-curve trend. And then this one and this one, asymptotic trend, exponential trend. I have a question. Which one, asymptotic or exponential? Which one is for new product trend? If a company launch new product, then which trend for that new product? Asymptotic or exponential? Anybody?
Exponential.
Exponential? Why?
Yeah,
It starts off a little slower at the beginning and then gradually works its way up. So I mean, that would probably be seen with a new product. It's slow in the beginning.
Yeah, great. Look at this. Product life cycle, introduction stage looks like this, right? So beginning, like Connor said, at the beginning, increasing rate is not much, but time goes, increasing rate increase. So typically, exponential trend is for the new product. And this one, asymptotic trend, about here. So already saturate product trend. So this part, increasing rate is high, but increasing rate decrease, and then later taper up, and then negative increasing rate. That means decreasing. Thank you, Connor. Okay, then types of forecasting, two types, qualitative and quantitative. Quantitative, without numeric data, quantitative using numeric data forecast. Qualitative, subjective and judgmental, because there is no numeric data, just opinion, based on opinion and forecast. Quantitative, there are two types again, time series analysis and causal relationship techniques. Time series analysis based on past data, numeric data. Time series and causal relationship techniques, difference between two. If when we use forecast, usually we try to develop equation. Y equals the same a plus bx. It's like this. A is intercept, and then b is slope, and then by the way, y-axis and then x-axis, and like this. So we call x variable as independent variable, y is dependent variable. I think you took statistics, math 155. So I think you familiar with variable, x variable, independent, y variable, dependent. So using x variable, forecast y variable. If x variable time change, then x variable change. And then based on this x variable, time change, then change in the x variable, then we call this time series data. So using time series data forecast that is time series analysis. So using past data, numeric data, time series data, predict. So using this time series analysis, we find trend, seasonal, and cyclical element pattern. Then using that element or pattern forecast. And causal relationship, demand is related to some underlying factor or factors. The same X variable, using X variable, find Y variable. Time series analysis and this causal relationship using regression analysis. But causal relationship like this, ice cream demand and the temperature. Temperature change, then ice cream demand change. Find the relationship, cause and like an effect. Same X variable using a kind of cause, and then Y variable, result or effect using regression analysis. So anyway, use numeric data, past data, forecast. That is quantitative forecasting. And next, some more in detail, qualitative techniques in forecasting. Judgmental method, the simple one in qualitative techniques. I joined this Marywood University in 2017, 3.5 years ago. Before that, I worked at certain school in Alabama, Montgomery, Alabama. In Montgomery area, Hyundai plant, there is Hyundai plant. So I had some relationship with the Hyundai people. Then at the time, I was interested in research about the automobile industry. And I asked Hyundai people, then what do you think about the next year's demand? Then they said, now Hyundai cars demand is good. So that trend will continue, and then we expect like a 10% increase. If I'm a dealer or if I'm a supplier, then I can prepare 10% increasing like the production plan or whatever plan. Without numeric data, past data, just opinion, based on their opinion, I can forecast like a 10%, 15% increase. That is the judgmental method. Example, jury of executive opinion. So like a CEO, top managers, their opinion. Or Salesforce composite. Ask a dealer, what do you think about the next year's demand? Yeah, increase, something like that. That is the judgmental method. And then secondary source information. Publish it, opinion. Maybe we can use like a Standard & Poor index or Wall Street Journal index, whatever. Then based on that index, opinion, forecast. That is secondary source information, such as consumer market survey. using consumer market survey and producer something survey and so on. Delphi method. This one is similar to judgmental method. Get opinion or information. Judgmental is like individual from individual people. But Delphi, structured communication technique, make a group by experts like an economist, practitioner, and so on, researchers and so on. Make a group, panel, and then ask them their opinion. Steps, choose the panel of experts, and then using like a questionnaire survey, ask them their opinions, and then summarize the result, and then redistribute again and again, and then until find the answer or forecasting. This is the Delphi method. So far, qualitative techniques. And next one, one types of the quantitative forecasting technique, time series analysis. You know, here, like an X variable, week or month, day, time change, then demand change. So this one is kind of time series data. Simple moving average, useful in removing the random fluctuations. The data again here. Up and down, up and down, up and down like this, raw data. If we use this raw data, then the forecasting may not be accurate. So many cases here, it says 7-day average daily test state wide, or it says today's reported the case 5,874, and then it says the 7-day moving average of newly reported cases was 5,028 on Wednesday, and then down from 5,969. So using 7-day moving average, add 7 days, previous 7 days, and then divide by 7, and then using that average for forecasting. That is a simple moving average technique to remove random fluctuation. Or using this moving average itself for forecasting. FT, term T, actual 1 term earlier plus actual 2 terms earlier, 3 terms earlier, and then divide by whatever. If we use 7-day, 7 terms, moving average divided by 7. Example, if we use 3 weeks moving average, simply add to get F4, forecasting term 4, actual 3 plus actual 2 plus actual 1 divided by 3, because you use 3 terms. So 1,000 plus 1,400 plus 800 divided by 3, then 1062. Maybe I can do it for a term next term. F5 equals A4 plus A2, 3 plus A2 divided by 3 again. A4 1500 plus A3 1000 plus, why isn't it diagonal? And A2 is 1400 and divided by 3. That it will be this one. And so on. So this is 3 terms, 3 weeks, moving average. And next, if we use 9 terms, then the same. Previous 9 terms to get F10 forecasting term 10, A9, 8 until 1, 9 terms, previous 9 terms divided by 9. So 1300 plus 1700 and so on divided by 9, that is this one. If we want to get 11s, add 10, 9, 8 until 2 divided by 9, then 1467 and so on. Simple, right? So this is simple moving average. If it is actual raw data, then if we use 3 weeks smooth, and then more weeks, more terms, more smooth and flat. Then using this smoothing, moving average, using moving average and the smoothing data for forecast, then more accurate. Okay. Next one, weighted moving average. Weighted moving average. Any weight to be placed on each element. You know, earlier using simple moving average, just add whatever terms divided by the number of terms. Simple. But sometimes the most recent data affect more important. That case, give higher weight. But the weight should be, some of the all weights should be 1, equal to 1. I will tell you with the example. So forecasting using weighted moving average, term T equals weight for that term plus weight and so on. If we use 0.4, if we forecast use 4 terms and then weight for the most recent 0.4, 0.3, 0.2, 0.1. If we forecast 4 terms, then we can distribute like this. It doesn't matter maybe the most recent one is very much important, then give higher like a 0.5, and then others like 0.2, 0.2, 0.1, whatever. But the sum of all weight should be 1. That means 100%. So if we use 0.4, 0.3, 0.2, 0.1 weights for the forecasting, then example like this. For term month 5, the most recent month 4, higher 0.4, plus 0.3 next term, one term earlier, and again one term earlier, and so on. So using weighted moving average, 97.5. That is weighted moving average. You know, for this class, I may quiz and assignment weight, quiz and assignment weight. Remember, was it 40%? And midterm 30, final 30%, like this. If you got like an 80% of all Q&A and 80% midterm, and then 90% final, like this, then 4 times 8, 3 times 8, 3 times 9, and so on, then your whatever weighted total, that will be your grade, final grade. So the grading system also weighted moving average, weighted not moving, weighted average. Okay. This practice problem in on Moodle. So you can find this now, practice problem on Moodle. Let's do this one together. Actually, I give you time to do this, but this one is an easy one. So just let's do it together. Using for 5 months, simple moving average, find the December forecast. So December forecast, F, change color. F, let's say 12 equals 5 months. So previous 5 months is data. Oops. Again. F12 equals previous 5 months. So add 23 plus 22 plus 20 plus 19 plus 19. Divide by 5 equals will be 123 divided by 5 equals 20.6. Simple. No question, right? It is too easy. Okay. Next one, using 4 months weighted moving average using 0.4, 0.3, 0.2, 0.1. Higher weight for more recent month. Forecast December F 12 or December equals 4 months. So using 4 months, the most recent 0.4 times most recent 23 plus next 0.3 times 22 plus next one 0.2 times 20 plus 0.1 times 19 equals 21.7. Simple and easy so far. Okay, any question? Good. Okay, next. Mm, 443. One more, then maybe 5 minutes more. Exponential smoothing. Same idea. The most recent occurrence data are more indicative of the future than those in the most recent, more recent, distant past. Using alpha, we call this one smoothing constant. Smoothing constant. This one is given. Sometimes it's 0.05, 0.01, whatever. So using this alpha, then using this formula, alpha times 1 minus alpha, 0 power, the most recent. So this is kind of weight. So the most recent data weight is higher than more distant data. So using this smoothing constant alpha forecast, using this formula, forecast term t equals forecast one term earlier plus alpha smoothing constant, usually it is given, actual data one term earlier, and then minus forecasting data one term earlier. Example, the last month's forecast So last month's forecast. This one is F T minus 1 is 22,000. And actual one term earlier, A T minus 1. And then alpha is 0.01. So FT minus 1, 22,000. Alpha is given 0.01. Actual 21,000 minus forecasting one term earlier, T minus 1, 22. So that is this. So using exponential smoothing technique, we can get this forecasting for term T. If we use this exponential smoothing technique, then one thing problem. Delaying problem, by the way, use lower alpha, then more smooth, higher alpha, closer to actual data. Then problem, lagging behind. If we use exponential smoothing technique, if actual demand data, highest point is here, but if we use 0.5 alpha, like one term delaying. Next one, lower alpha, one term more delay, and so on like this. So delaying problem. So using another smoothing constant, delta, then correct that error. So using alpha and one more delta. So smoothing constant delta reduces the impact of the error that occurs between the actual and then forecast. That is exponential smoothing with trend. Looks like this, more complicated than other techniques. Stop here and then continue on Monday. Question? Okay, no pop-up quiz or no pop-up assignment. Instead, I decided on one more week online, and then after next Wednesday, decide again if we extend the online longer or not. I didn't visit campus yet, so sometime later I will go to our classroom, and then how many seats available. I will look at it and then let you know how many you can attend if we go back to in-person class face-to-face. Any question or concern? Good.
Just that pop-up assignment is due Saturday by midnight?
Saturday, yeah.
Okay.
The pop-up now, the purpose of giving you a pop-up assignment or quiz is like I said earlier, encourage you and then engage you. And also one more purpose is track you. If you are still in, okay? When I give you a pop-up, whatever, then I will not give you something hard one, just a casual thing, okay? So I hope you keep going, okay? Okay, if you don't have a question, then that's it. And have a nice days, weekend, and then see you next Monday. And then keep safe, okay? Okay, bye.
Have a good week.
Bye.
Have a nice day.
Thank you.
Have a
Take
nice
care.
week.
Have a good weekend.
Thank you.